We're with LunaTrex. They're a Google Lunar X PRIZE competitor. And welcome. If you guys could really quickly introduce who you are and your role at LunaTrex.
Sure. My name is Pete Batar, and I want to introduce my team here. This is Mary Cafasso, Greg Allison, and Rick Wills. These are three of the folks that have joined me here at this event. We have another probably dozen people on the team and that are not here, but LunaTrex is Google Lunar X PRIZE team, as you mentioned. And we were formed at the beginning of this year, just before the announcement was made at Google headquarters to kick the the main kickoff event. We're one of the original 10 teams. LunaTrex, the idea with the name was obviously Luna for the moon, and Trex. First of all, Trek by itself was already taken as a .com, so we went ahead and went for an X at the end to kind of pay tribute to the X Prize, as well as the multiplicity, the idea of not only building a system that can do this one time, go to the moon, put a rover on the moon, have it travel 500 meters and send back high definition video, but the capability to repeat it. And so affordable and repeatable space missions like this is sort of the goal of the team. We were formed originally to kind of create a small sat turnkey ground ops and full up mission center for small business and universities to be able to access space. And that was sort of the original business plan. The Google Lunar X Prize came along, and we thought, we have the same capabilities necessary to do this, so why not pursue it? And so that's been sort of our motivation.
So your original business plan was a little bit different then, right? I mean, you were going to put satellites in space as opposed to actually putting rovers on the moon.
Right, but actually one of the possibilities was also deep space exploration, doing small probes using electric propulsion drives to go to the asteroids and other outside of just our orbit bodies. And so that was part of the motivation in the longer term business plan, and obviously that's been accelerated with the GLXP, but that was actually part of the whole business plan. And the truth is once you get something into orbit, taking it out of orbit and sending it somewhere is not all that much more difficult in terms of all the infrastructure that's necessary to do those things.
So what are some of the things that are difficult to do in, say, putting a rover on the moon and sending back high definition video?
I'm going to let Mary answer that question because she has a good answer for it.
Yes, first of all, obviously, we're here today at the Lunar Lander Challenge, and the most difficult issue is getting off the Earth and on the Moon. Those are the two most difficult as far as the technical discipline goes, but I'll let you all know that the real technical, the real tough part of this is management. Okay? Managing the entire effort, and it's a large effort, is very, very difficult. And you have to manage by outsourcing, subcontracting, so it's not just managing your team, it's managing the entire program from beginning to end, which is why you have to have the right team. And keep it small because it's got to be cost effective, but the right type of people, the right companies involved with the right discipline, and a lot of management experience in aerospace. Some of our other members that are here represent some of our consortium companies. Greg Allison behind me represents HARC, and he can talk a little bit about that. And Rick is one of our professional aerospace engineers in propulsion, and he can talk about his experience in space. But in general, we have a team of experienced aerospace engineering companies with decades of experience behind us. And we're going to keep that team small, and we're going to outsource it and manage the program.
Now, how much can you outsource? Because, and I know the rules are not finalized for the Google Lunar X Prize quite yet, but it was my understanding that something along the lines of like 90% of the vehicle or the rover needs to be done with non-government material. Is that correct? But does that, you can still outsource that to non-government companies like SpaceX or something like that?
Absolutely, and we're not closed in terms of like the core team. That we want to remain small. However, the alliances that comprise Team LunaTrex as an alliance or as a consortium could be as big as we want it to be. And so could team members include large aerospace companies? Absolutely. Could they include companies from other countries? Absolutely. We're not closed, and we're not sort of focused on any one particular region or even country, but we're kind of looking at a broader consortium and group of things.
Can you touch on some of the alliances that you've already formed? Or not really? Or would you, if you prefer?
Well, I mean, we can touch on it in generically. We're not allowed to talk about certain companies at this point yet. But generically, we have talked to some very prominent, easily recognizable household type name companies for major aerospace companies for things like the electrical propulsion drive, the satellite buses, and obviously the launch. We're probably a small enough package that will be a secondary payload on another launch. So that is, obviously something we have to work with somebody bigger on.
Yeah, well, because you're not required to launch yourself.
Correct.
So you just need to get your vehicle. Actually, you don't even need to get the rover on the moon, I don't believe. You have to just have the rover on the moon to be able to control it. Is that correct?
And we are working with different companies to explore the possibilities of who's going to be the best at creating the things that we need to our spec. Whether that be, and I think the uniqueness is we're not inventing anything to do this. We're taking things that are relatively proven and off the shelf and combining them in unique ways. Could that be patented? Yes, because it's not necessarily something that's been done before. But honestly, one of our tenets was creating an electrical propulsion system to get to the moon and take several months to get there rather than just 3 days like everybody else is looking at doing. What does that do for us? Well, you trade time for weight. And so since we don't have a man in the loop, we don't need to supply anything but electrical power, which we're going to have to supply anyway. So, if it takes us 6 months to get to the moon, who cares? I mean, unless somebody knows we did it and can beat us there. But the bottom line is we're shaving, 2/3 of the weight off the mission, and that's enormous. And when you talk about an average of $1 million a pound to actually land something on the moon, you take 2/3 of that away, that suddenly makes it affordable. And one of our big goals is to actually do the prize for less than the prize money. I think that's a big part of the point. Is if you do it for $100 million and you win 20 million. Well, what have you proven there? I don't understand the logic of that. People are saying, well, it's just to prove that you can do it because the government would cost so much more. And it's like, well, yeah, but if you really can look at this thing piece by piece and trim each part of the budget and succeed and repeat it, then you really have something there that suddenly makes space truly affordable and makes it something that I think will draw more interest rather than less. It doesn't, a $100 million mission doesn't take that kind of thing out of the domain of just big companies and governments. But if you could do it for 10 million or 15 million, now all of a sudden you're in the range that a consortium of universities or small businesses could actually have capabilities that explore the moon.
Well, I got to say that's going to be insane, crazy difficult because just the launch alone is going to be extremely costly.
Well, but see, if your launch package is light, your launch could be as little as $2 or $3 million for a secondary payload. Everybody else is looking at $20, $30, $40 million. Well, yeah, if you're going to launch 1,000, 1,500, 2,000, 5,000, whatever pounds, yes, absolutely. But it's a function of weight. If we can get our payload down to 300 kilograms, which is our goal, then we're in that game for $3 to maybe $5 million for the launch. That's the biggest part of the launch. The satellite buses. $2.5 to $3 million. There are companies that are making those now in that weight class. The electric propulsion is not that expensive. The rover design, you start putting these things together, and it's like, yeah, it pencils out. And actually, we've had some big companies look at our program and said, of all the companies out there doing this, you guys is the only one that pencils for less than the prize money. And we've worked really hard. And Mary's right. The management is the issue. How do you take all those elements and manage it and then trim the cost out of it in the right way?
I think the webcast has a question.
Yeah, actually, they were wondering. I don't have a mic.
You don't have a mic.
Sorry. The webcast is commenting on how you were saying you wanted to get to the moon. You weren't concerned about how fast to get to the moon. And so then somebody brought up the point of, well, then you have to deal with the environment for a longer amount of time. Can you address that at all?
Sure. Actually, I should probably let one of you guys address it better. Why don't you?
They are calling for Greg, if that makes any difference to you.
Well, one of the things I pay a lot of attention to is avionics in space. By the way, I'm president of HARC, Altitude Research Corporation. I'm Greg Allison. And HARC specializes in systems engineering, propulsion, and logistics. Personally, I have a double E background and have done a lot of rocket development. One of the key things you've got to be able to do is survive the radiation environment. That's the biggest challenge of getting to the moon when you're going slow. So what you have to do is make sure that the parts you have are the best you can get, what we call grade 1 parts in the aerospace world. So we'll pay a lot of attention to what goes into the spacecraft just so that we can be sure that it's got a reasonable chance of survival. Those things are more expensive, but you know, you got to trade off between do you want to carry a lot of fuel, which is very expensive, or do you want to buy more expensive parts? And I think the parts is the best trade for what we're trying to do.
Yeah.
Is there anything else you're going to do to space harden it? Just outside, I mean, so you're going to do better parts, but what else will you do to space harden it?
There are other ways to space harden, and primarily it's mass. If you can put more structure around your avionics, you have less chance of getting an energetic proton or electron penetrating and causing a single event upset with your avionics. Or various other problems that you can get, like the memory losses, turning zeros to ones and ones to zeros in your memory. So
that's not good.
But the single event upsets is the real ones that you worry about the most. So then you got to worry about things like coronal mass ejections from the sun if you just happen to be out there and the space weather turns really bad. So there's a number of things you watch. Sometimes some of his operations, if you're going to get the coronal mass ejection from the sun, you'd shut stuff down basically and try to protect your craft that way. So there's a lot of things to take in consideration, but it can be dealt with. And we're for the lowest cost approach to getting this done. I think that's the way to go at it.
One of the other factors I'd just like to share with whoever asked a very good question is the initial orbit injection will make a big difference. It's how long you stay in the radiation belts, and that becomes a big part of the trade study. And there are some very powerful launch vehicles out there, and depending on which payload you attach yourself to, you might be able to get out of the radiation belt relatively quickly.
Is it just the Van Allen belts you're worried about, or you once you get past them?
Well, the majority is close to Earth in the Van Allen belts, and also there is other radiation to deal with, but that's a very small dose compared to, and as Greg was telling, it's single event upsets. And of course, the design of your space vehicle and your rover being fault tolerant and having redundancy will also help in the right places.
I'm a safety guy. I believe in a little redundancy in our systems. That's one of my other hats I wear. So, yes, Mary's right. The Van Allen belts are the primary area of radiation intensity, but once you leave Earth's protective zones, you are subject to the environment itself of space, of deep space. So we're looking at being able to go to asteroids and stuff like that down the road. So we have to design with that kind of philosophy from the beginning for our corporate objectives.
Do you have additional questions from the webcast?
Yeah, actually.
Mike?
Oh, sorry. I'm not loud enough? What are you talking about? I have someone named Rob Goldsmith who said that when he spoke last with Pete, that he had quoted John Carmack saying, "Once a year presentations are the worst thing for a technical challenge." Can you expand on this? Apparently you quoted John.
In what context?
That I don't know.
That's a good question. I don't remember.
But yeah, I figured I'd put it out.
Say the question again.
Okay, so Rob Goldsmith said, when I spoke to Pete, he quoted John Carmack saying, "Once a year presentations are the worst thing for a technical challenge."
I think maybe he might be thinking of a different interview, but
right on.
I guess I could look at that and say, I'm not really sure about the worst thing, but once a year. I'm not sure how that.
He must be talking about these.
Yeah, maybe these kinds of events. I don't know. I'm not sure I completely understand the question, but I agree that we should be doing more events to bring awareness to this thing, because one of the biggest challenges that we're facing at this point is capital raising and sponsorships.
You must have said it because he has it in an article.
With
Space Fellowship.
From me? my quote? I don't remember ever quoting John Carmack.
That's all right.
Or ever being quoted by Jeff Faust in space.
Yeah, exactly.
But the point is, you'd like to see more events to get awareness of space.
Yeah, absolutely.
higher.
I mean,
think that's-
the spirit of what he's asking is right. I think that the opportunity to get this thing out in front of more people, exposure, just like what you guys are trying to do, is very critical to the space industry in general, especially new space. And in terms of Google Lunar X Prize teams, events that highlight this process will only help us accelerate that process.
For sure. Someone is asking about your funding. I don't know if you want to actually speak to that or.
Yeah, actually, we're clipping along. We're in the process. Some of you may know that I own a defense company, and we're working on actually selling that company off. And part of that funding will go to this. It could raise as much as 40% of our total need.
Wow.
I've committed a lot of my personal resources to this mission because I believe in it so much.
We understand that.
I think that that's important. And I think that having a personal stake in it will also draw sponsorships and investors.
For sure.
And so, in terms of the total of what we're trying to do, I think we're well on the way to doing that. To this point, we've all been relatively volunteer labor, and we're hoping that starting in 2009, we'll start actually creating payroll and putting down payments on components. So
awesome.
that's exciting.
Awesome.
So if I may, lunar dust is a nasty little thing. It is not fun. How are you going to deal with these little pieces of lunar dust and rock and everything just gumming everything up?
Well, right now, I'm Rick Wills. I'm one of the aerospace engineers on the team. Lunar dust has always been a challenge. It started, we discovering that from the first lunar missions. Part of it is design, and part of it is test. We're going to, there's a lot of regular simulants out there now we can use, and we'll use those liberally, and part of it is how we design our system, and we understand the problems of lunar dust. So between the testing and a good design using the right materials, I think we can get something that's going to get us in operational needs to move the 500 meters. And if we do it right, it'll go beyond 500 meters. We'd like to make it roll a lot further than 500 meters.
Are you going for the? I don't remember the constraints of the Google Lunar X Prize, but I know there's, if you could go even further, there's an additional prize.
We would certainly look at that as one possibility. There are many possibilities to win the extra prizes. The staying all, surviving one lunar day, night, that's certainly a possibility. Being able to accurately land enough near some appropriate Apollo site, or maybe a Soviet site that someone's landed on, and go up and take pictures of it. That's the sort of thing. Those are certainly in our venue, and we're considering those greatly.
Is there anything neat on the vehicle that's going to be just kind of a different way of doing things?
We're not going to talk about that just yet, but I'm
How about broad strokes?
The whole vehicle is cool, just in and of itself.
Will be rather unique. I think the way we get there and the way we land and our roving is going to, you'll find, I don't think we'll probably announce anything probably next year, but I'm certain once we announce it, you'll find it's pretty unique.
I'm not going to say anything that's revealing, but I will say that we are looking at design solutions that take into account the dust and mitigate very well for what we anticipate those problems to be.
So after the Google Lunar X Prize is complete and you win.
Actually, can I, really quickly?
Yeah.
Just along the lines of lunar dust, because it did come up then in the chat room. They're wondering if you have, if you've been testing in anything along those lines to kind of.
We haven't started testing. Yeah, it's way.
That's kind of what I figured. Okay, so there you go, guys.
We're aware. We know where to get the regular simulant. We have a lot of design issues that have been already looked at. And we've looked at a lot of history. If you go on the web, there's hundreds of documents that have been made public by Apollo, and I think my little 16 gigabyte chip, I probably got 10 gigabytes of documents like that.
Right,
so
right.
And we've been reading all those for last year since we started this program. So we're understanding the problem.
Good.
And it's just the next step you take is what sort of suggestions do we have. Like Greg said, we've looked at a lot of design solutions. We haven't just stopped at what they did in the 70s. We're looking at with modern materials, and computing capacity is phenomenal for doing mechanical simulations. So that's one thing we're taking advantage of.
And just keep in mind too, we're only a 9-month-old team. I mean, we've only been doing this for a short period of time. So we're still, the team is really gelling well together. We finished our work breakdown study to level 4. We really have a lot of things going for us in terms of the infrastructure upon which to go forward with. And like I say, in 2009 we'll start bringing people on with some salaries, at least part-time, and also start putting some down payments on components so that by the end of the year we'll have a much better idea of what the whole system design will be. But you're not going to see hardware being tested until probably 2010 at least. And that's just the nature of it. But we have, 4 years and a few months from today to finish the prize. So it's we're not in a huge rush.
Well, it's really hard. I'm not sure that everyone, space newbies or just kind of general space enthusiasts may or may not understand exactly how many obstacles you have to overcome to get on the moon, and then even once you're on the moon, just even thinking about things, did you even consider moon dust? That stuff is, like I said, it's nasty. Just little things like that all throughout the entire mission, and that's assuming that launch goes off without a hitch.
Sure, exactly, and that's why we're trying to work with other companies that are professionals in their sphere, that we don't have to learn something from scratch. We're not building anything from scratch or inventing anything except for maybe the rover. And even then, we're going to be working with other people that know different elements of the rover so that our components that go into it are well proven out and have a lot of redundancy and some fail safes. And going 500 meters, it's really not that bad. Trying to survive for months on the moon would be a completely different game, though. So
that question came up about how are you going to keep warm through the moon night? They're worried about being cold, apparently.
Blankets.
Blankets, yes.
Well, right now we're in the process of dealing with all those issues. We do not have the rover completely designed, and certainly we don't have the thermal analysis done. But of course, that's something we are going to go after the bonus prizes. So that is something that we will have to design in, and that is something we will have to consider in our requirements. In our system decomposition, as Pete was saying, we're to a certain level of system engineering at this point. We're to a requirements level, and we're still working with the X Prize Foundation on the rules. And so until those rules are really solidified, we won't know the final requirements in order to proceed with the design of the entire mission. We can tell you that we have several ROMs out there for several phases of the mission, like launch vehicle, things we know we're going to need, and propulsion. The other thing is we're starting a system decomposition in the right place. I don't think you'll hear from many Google Lunar X Prize teams that you start with operational needs.
Right.
Okay? And you got to do the mission ops first. Okay. How you're going to operate. And you decompose from operational needs on down to the system requirements, and you have to do that correctly, or you're going to find out it's very difficult to operate on the moon. Right. So we're going to try and learn from all the past experience, obviously, and do it cheaper and better, and proceed along our business plan. And I think that we've got a good chance at winning this. In fact, I think, and I'll be a little bit forward on this one, we're going to win.
Awesome. We unfortunately have to wrap this up.
All right. Well, where can people go for more information?
Yeah, LunaTrex.com, LunaTrex.com, or you can check us out on the Google Lunar website, Google Lunar X Prize website. By the way, I just wanted to say thanks to all our fans who voted us 7-1 the most popular team on the.
I think it was the hat.
There might have been the hat. Actually, that hat will be on the moon someday. No, but I wanted to again thank our fan base for that. I think we had 720 some odd votes of the 1,012 votes cast for all 12 teams at the time. So we're very excited about that. Thank you to our fans. Thank you to the X Prize Foundation, and to you folks today. Thank you very much.
Yeah, thanks a lot.
Thank you.
Thanks for being on.
Yeah, absolutely.
All right.